Please pause the video and read the problem. Okay, let me explain this example. First, we should understand how many events are in this example. There are two major events. First, let me define these two events. I say D, disease is present, and A, test is positive. According to this example, there are two types of people or two groups of people. What are these two groups? One group, people who have the disease. The other group, people who do not have the disease. Right. Now let me write down given probabilities. First, a lab test is 95% effective at detecting a disease. Right. If I stop this sentence at that point, 95% is what? That is the probability of A, because A is the event that test is positive. But we have a condition. What is the condition? When it is present. So that means disease is present. So D is the condition. Therefore, this becomes a conditional probability. How do we write this? We can write probability A given D equal 0.95. Similarly, next one, it is 99% effective at declaring a subject negative. Again, if I stop this sentence at that point, what is the subject negative? We know subject is positive, that means test is positive, it is A. But here negative, therefore it should be A complement. If so, we can write probability of A complement is 0.99. But again, we have a condition here. What is the condition? When the subject is truly negative. We know the subject is truly positive, that means disease is present, that is D. So the subject is truly negative, then we can use D complement. Now we can write this probability of A complement, that's right, given D complement, that is 0.99. Then the last part, suppose 8% of the population has the disease. We know disease is present at the event D, so probability of D equal 0.08. Now let me explain this using a Venn diagram. As I mentioned before, our sample space is people. There are only two groups of people. People who have the disease and people who do not have the disease. So I can draw the Venn diagram and divide into two parts, D and D complement. How about now A? Test is positive. We know, consider the group D. In the group D, there are some people that test is positive. That is A, right? And similarly, in the group D complement, there are some people that test is positive. Therefore, I can draw A like this for the both parts. Now A has two portions or two parts. One is A intersection D and other one is A intersection D complement. What is the A intersection D? A is test is positive, D is disease is present. Actually, A intersection D is the correct decision, right? Because disease is present and test is positive. But other part, A intersection D complement. A is the test is positive, but the complement is disease is absent. That people who do not have the disease. Actually, it is false result. Right. However, let me go to the part A. What is the probability a randomly selected subject will test positively? That means event A test is positive. So ask him probability of A. So how do we find the probability of A? We know by the law of total probability we can write probability of A equal probability of A given D times probability of D plus probability of A given D complement times probability of D complement. If you don't know how to come to this or how to derive this, you can go to my previous video and watch it. I explain how to derive this part on that video. Right. Now go back to the example. Here we know probability of A given D is given, that is 0.95. How about the probability of D? Yes, it is also given. But we don't have probability of A given D complement and also probability of D complement. Now we can write these two, 1 minus probability of A complement given D complement times 1 minus probability of D. Right? Now we have all probabilities. Now you can plug the numbers and get the answer. Then probability of A equal 0.085. Now go to the part B. What is the probability a subject has the disease if his test is positive? Okay, now ask him the probability a subject has the disease. That means probability of D. But there is a condition here. If his test is positive, that is A. Right? A is the condition. Therefore, they are asking probability D given A. You know Bayes rule. By the Bayes rule, we can write probability of D given A equal probability of A given D times probability of D divided by actually probability of A. We know we found this one in the part A. Right. So again I can write down in a similar way, and now we know all the probabilities, then plug the numbers and get the answer. So this is the probability of D given A.